Well, howdy, folks, and welcome back. And we are beginning Unit 7. And Unit 7 is all about stoichiometry. And to get into stoichiometry, we have to first understand a concept called the mole. So let us begin with the mole, and this consider eating 7.00 moles of Krispy Kreme donuts. Oh, how many donuts do you eat? Don't. All right, 7 moles. Now, what's a mole? It's not an animal. No, it is a term we use in chemistry. So let us talk about the mole. And let me give you a couple definitions. Here's what I would call the most general definition, and it probably won't get you many points on a quiz or test, but to me, it's really an adequate definition. And here it is. A mole is a measurement. It is a measure of quantity. And it's a measure of quantity in the form of number. It is a measure of number. Got it? So what is a measure of number? I don't really know what you're talking about. Sure you do. If I said a pair, you would know that means what? Two. So a pair is a measure of number. What about, so we're talking about donuts, so we usually buy donuts in dozens, right? So what is a dozen? A dozen we know all means 12. Good. So we have that. How about a gross? A gross is a measure of number. It is what? 144. That's a dozen. And then we can have a mole. By the way, the abbreviation for a mole is MOL. And what is a mole? Well, it's not 2, it's not 12, it's not 144, it's not 144 times 144. It is 6.022 times 10 to the 23rd. Ach du lieber. 23 places. Oh my gosh. That is one huge number. Absolutely it is. 6.022 times 10 to the 23rd. Now, what are my units for this? My units are, my units for the mole are, well, they can just be anything. Now, this is kind of the general definition of the mole, a measurement of number, a measurement of quantity, but I don't think that'll get you points. Here is your chemistry definition, and this is the one I want you to know. Here's your chemistry definition of the mole. It is I better make that large. Avogadro's, he's some dude. He was some dude, he's no longer alive. Avogadro's number of particles. That is my chemistry definition. Now, what is my Avogadro's number? Well, Avogadro's number, you guys can all guess, turns out to be 6.022 times 10 to the 23rd. And my units on this are particles per mole. Okay? So the units on Avogadro's are particles per mole. Now, what's this concept of a particle? Well, particles, the four biggies, the four big types of particles we have are what? Well, an atom is a particle. An ion is a particle. A molecule is a particle. And then, of course, the equivalent of molecules for ionic compounds is the formula unit. So when we say particles, we can insert any of these four. So we could talk about particles per mole. We can talk about atoms per mole. I can talk about 6.022 times 10 to the 23rd ions per mole. I can talk about molecules per mole, and I can talk about 6.022 times 10 to the 23rd foods, formula units per mole. Got it? Okay, so this is what we're going to work with. This is the definition I want us to know. Avogadro's number of particles, and I want you to know that Avogadro's number is 6.022 times 10 to the 23rd particles per mole, and that particles are atoms, ions, molecules, and formula units. Good. I think we can answer this now. Now, The approach I'm going to use to solve most of these problems is something called dimensional analysis. And in dimensional analysis, I want to find an equivalency. So 1 mole is equal to 6.022 times 10 to the 23rd. And what are we dealing with here? Donuts. So 1 mole of donuts equals 6.022 times 10 to the 23rd donuts, right? So I have an equivalency. I have something that equals something. Now, I want to change that into a fraction, okay? Now change that to a fraction. I'm going to put one of these in the numerator and one into the denominator. I'm going to multiply that fraction by what is given, 7.00 times 10, excuse me, 7.00 moles. And what is it that I want to know? I want to know the number of donuts. Donuts. How many donuts are equal to 7.00 moles? Now, I'm going to take my fraction, and what I want to get rid of, I'm going to put in my denominator. I want to get rid of moles. So that means I want to put moles in denominators from my equivalence, right? My equality, excuse me. So I have 1 mole of donuts, and what goes in the numerator? The other part of my equality, 6.022 times 10 to the 23rd donuts. Good. Now, if I just look at my units, I have 7 moles, I have 7 moles times donuts over moles, right? Good. So what happens to my moles? My moles cancel, and I'm left with donuts. So that's what I'm looking for. I'm looking for donuts. So I take 7.000 times 6.022 times 10 to the 23rd, and I get 4.2154 times 10 to the 24th. But I have to look for what? Sig figs. 4 sigs here, 4 sig figs, meaning how many sigs can I have in my answer? 4, 4.215 times 10 to the 24th. And what are my units? What are my units? Donuts. Donuts. Especially, not especially, specifically Krispy Kreme donuts. So if I have 7 moles of donuts, I have a whole bunch of donuts. That would even keep Homer satisfied. All right, moving on. Here we go. Consider methane. How many atoms of hydrogen are in each molecule of methane? Why is this question here? Where's moles? I don't see any moles in here. Well, you're right, but this is setting up another question coming later. So how do we work through this? Well, let's look at methane. You remember meth means I have 1 carbon, and there are 4 hydrogens on the carbon because it's methane. They're all single bonded. Well, there's only 1 carbon, so there's no double bonding going on if I only have 1 carbon. Good. That means I have CH4, right? And that is what? That's the formula for my molecule, right? Cool. So what's my equivalent? What's my equality here? I have 1 molecule of methane, and that is equal to how many atoms? Well, there are 4 atoms of hydrogen, right? There are 4 atoms of hydrogen in every carbon. So there's 4 atoms of hydrogen, and how many atoms of carbon? 1 carbon, right? Good. So if I have 1 molecule, I have 4 atoms of hydrogen. All right. And so this I can later turn into what? I can turn it into a fraction and use it in dimensional analysis. All right. Here we go. You guys give this one a shot. Consider 1.872 moles of silver. How many atoms are there? Bring me back when you're ready. Okay, here we go. I have what? Let's set up my equality. I have moles of silver. I have 1 moles of silver, and if I have moles of silver, 1 mole of silver is always equal to what? 6.022 times 10 to the 23rd what? Atoms of silver. So that's my equality. What is my given? I have 1.872 moles of silver. And what is it that I want? I want to know atoms of silver. So how many atoms of silver are there? That's what I'm seeking. I'm going to have my fraction. What is it that I want? I want atoms of silver, so I'm going to put that on the top. 6.022 times 10 to the 23rd atoms of silver. What goes in my denominator? What I want to get rid of? I want to get rid of that pup, right? So I'm going to put 1 mole of silver. Good. Moles of silver cancel. What am I left with? Atoms of silver. Is that what I'm looking for? Sure am. So now I know it is set up properly. I'm going to take 1.872 times 6.022 times 10 to the 23rd. And what do I get? 1.127. 4 sig figs, 4 sig figs, times 10 to the 24th. What? What? Right here. Atoms of silver. Yahoo! By the way, that is a point, not a, there we go, comma. 1.127. Excellent. Moving on. You guys give this one a shot. Bring me back when you're ready. Okay, I have I have 182.3 moles of sulfur trioxide. I want to know molecules. Okay, do we have a relationship between moles and molecules? Sure. 1 mole of sulfur trioxide equals what? 6.022 times 10 to the 23rd molecules of sulfur trioxide. Now note, folks, here's a note. Where should I put my note? Note. Write all of the units. Write them not just in your answer, but as you set up the problem. Write your units all the time. This is key to being able to do these problems well. All right, good. What am I given? I am given 182.3 moles of sulfur trioxide. And what do I want to get out of that? I want to get molecules of sulfur trioxide. And what am I going to do? I'm going to set up a fraction. What goes on the top? What is it that I want? I want molecules. So molecules, 6.022 times 10 to the 23rd molecules of sulfur trioxide. What goes on the bottom? Well, my 1 mole of sulfur trioxide, and if I'm lucky and did this right, it will cancel out with what's given, and indeed it does. And so we just now write down the answer. 182.3 times 6.022 times 10 to the 23rd, and I get 1.09781 times 10 to the 26. Now, how many sig figs can I get out of that? 4 here, 4 there, so I can only get 4 sig figs. So it is 1.097 rounds to 8 times 10 to the 26. What? Molecules. Molecules of SO3. Great. That is our answer. Now, how many atoms of sulfur are in the sample? Well, hey, we go back to what we did with methane, right? How many atoms of sulfur are in one molecule? I have 1 molecule of sulfur trioxide, and I look at that and I say, oh, that's easy. There's 1 atom of sulfur in every molecule, so I have what? 1.09781 times 10 to the 26th. I'm going to underline that. That means that's not significant. And what is that? That is molecules of SO3 times what? 1 atom of sulfur times 1 molecule of SO3. And so I get 1.0, and we have to round to 4 sig figs, right? 1.098 times 10 to the 26 atoms of sulfur. Now notice, folks, I put in my unrounded amount here. Yeah, we don't want to round until we get to our final answer. And you'll see in this next question, you would get a different answer if you use the rounded amount. Okay, here we go. How many atoms of oxygen are in the sample? Well, I have 1 molecule of sulfur trioxide. And when I look at that, I can see how many atoms of sulfur. Well, I have what? 3 atoms of, not sulfur, oxygen. 3 atoms of oxygen per, oops, excuse me. There are 3 atoms of oxygen in every 1 molecule of SO3. So let's go back. We want to know how many atoms of oxygen are in my sample. We have 1.09781. I underline those guys telling me they're not significant, but I got to use them because I can't round. I don't want to round till the end. Times 10 to the 26 molecules of what? Molecules of SO3 times what? I have 3 atoms of oxygen per every molecule of SO3. What happens to my molecules of SO3? They cancel. So times 3, and I get what? How about 3.293 times 10 to the 26 atoms of oxygen? Hee hee! That's a whole bunch of oxygen atoms. That is correct. All right, one last, and we will take a break. Here we go. We'll do this one together. Okay, I have 27.25 moles of chromium 2 chloride. Okay, I have moles, and what do I want? I want formula units. Ay, 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 what's a formula unit? Oh, I remember. Formula units are what? Particles. That means 1 mole of an ionic compound, in this case chromium 2 chloride, has what? 6.022 times 10 to the 23rd formula units of chromium 2 chloride, right? So this is my equality, 27.25 moles of chromium 2 chloride times what? 6.022 times 10 to the 23rd formula units of chromium chloride per what? Per 1 mole of chromium 2 chloride. Cool. My moles of chromium 2 chloride cancel, and I am left with 27.25 times what? 6.022 times 10 to the 23rd. Woohoo! And I get 1.64, and I have 0.99, but I only have 4 sig figs here, 4 sig figs there. I can only have 4 in my answer, so that rounds to a 1 times 10 to the 25th. What? What are my units? Formula units of chromium 2 chloride. Oops, chromium. That's not right. Chromium 2 chloride. That means my chromium has a +2 charge. Yahoo! Okay, there we go. Let's call it quits for the day. Ciao.